All right, hey guys, it's Wednesday. Welcome back to Pre-Calculus. Hope Tuesday went okay for you because I've only had one student reach out to me about any of the problems. So good job, Evan. You guys are going to need your identities that we talked about on Tuesday. So hopefully you have your notebook nearby or this is printed out somehow. So you can refer to that pretty quickly. Today, before the break, I mentioned something about geometric proofs. If you guys had remembered those, not that that's what we're doing, but something very, very similar. Today we are verifying trigonometric identities, which is a lot like solving a puzzle. There's more than one way to do it. So the way I'm doing it, the way I put it together, is not necessarily the only way to put it together. It's just my way of thinking. And I always love watching you guys do these because you guys always come up with a different way of thinking about it. And I love that. So don't feel that my, my way is the only way to get this done. So here we go. So verifying trig identities. Okay, so we have a new page, new title, new table of contents. I don't know what page you guys are on, but this is what you're gonna want to write down in your notebook as notes for today. And then we have 6 or 7 verifying problems to go through. So if you want to take a moment, pause the video so that you can write this down. Now will be a good time to do so. In the meantime, I am going to start talking about the rules and what we want to do so that we get down here and kind of have an idea of what we're doing. So you're going to choose. You're either going to choose the left or the right side to do. You can't do both. You have to choose one side or the other to work on. So when we look at problem number 1, the left-hand side has a whole lot more stuff on it, and we might be able to do some things to that, where the 1, you could literally turn the 1 into anything you wanted to. So I'm going to suggest that you stick with the side that already has stuff on it. So my suggestion is that you work on the left-hand side of this problem. We cannot move from one side to the other. In other words, if you're solving an equation, you can't add 2 to both sides here. We're not solving an equation. We are simplifying. In other words, we're staying on one side. That equals 1 is not going to move. We're going to leave it exactly right there. And the work for these problems is showing everything you're doing. Assume that I know nothing and that you have to prove it to me. So if it's an identity, you need to write it down and show me what's going on. Okay? All right. So let's take a look at problem number 1. What can we do to get the left-hand side to equal the right-hand side? So yesterday, when we were working on simplifying, one of the things I mentioned is to separate these into 3 different fractions. So tangent x times cosine x times 1 over sine x. And yesterday, as we're simplifying, we want to turn everything into sines and cosines. And so the tangent, using a quotient identity, can be turned into sine x over cosine x. Sorry guys, I'll move that up. The cosine x is going to stay cosine x, and the 1 over sine x is going to stay 1 over sine x. And at this point, we'll get some cancellation. Sine x cancels with sine x, cosine x cancels with cosine x, and what do you have left? You have a 1. You have this 1 right here, which matches the 1 on the right-hand side, and we have verified. Verified. There we go. So that's what the problem will look like. And this is the work. So if and when we take a test on this, this is how you would turn in your work. The answer is all of this, not just one. Okay, it's all of that right there. So that's the first one. All right, so we're just going to go through some of these, show you what they look like, some of the different types of problems. Typically, I'm a left-hand worker, meaning that I'm always going to work on the left-hand side and make the left-hand side match the right-hand side. Okay, so trick to this problem is separating the top and the bottom into two different fractions. 1 plus tangent squared x times 1 over cosecant squared x. Okay? All right. So, we want to turn things into sines and cosines. So, the green here, this is a Pythagorean identity. I'll bring my little identities in right here. Tangent squared theta plus 1 equals secant squared theta. Okay, so 1 plus tangent squared x turned into secant squared x by Pythagorean identity. The 1 over cosecant squared, you have 1 over cosecant right here, so we can turn that into squares. So we will reciprocate this and call this sine squared x. Okay, and continuing with turning things into sines and cosines, the secant squared x turns into 1 over cosine squared x. Sine stays, sine x. We will now push these two together, make them one fraction. Sine squared x over cosine squared x. So we pushed them together, put the sine on top and the cosine on bottom, just pushed them together. And sine squared x over cosine squared x is a quotient identity. That's sine over cosine. We can make them both squared as long as we square the tangent. So this is tangent squared x, which matches tangent squared x. So that's problem number 2. And we'll just keep working some problems, let you see what it is that will happen. All right, so on number 3, what you might notice is that each one of these has a cosine squared. Now Again, this is just my thinking of this, okay? And this is a technique that's going to come in handy later on when you get into some tougher problems. There are other ways to do this, and so you may be thinking of another way to do this. So just bear with me. Watch what I'm going to do. I'm going to factor the cosine squared x out of this problem. So cosine squared x. And so cosine squared divided by cosine squared is 1. The plus sign plus cosine squared tangent squared divided by cosine squared is tangent squared x. Okay. The cosine squared x I'm going to leave as cosine squared x because we want to turn things into sines and cosines. So this is going to remain as cosine squared x. The 1 plus tangent squared, again, tangent squared plus 1 is secant squared. That just turned into secant squared x. Cosine squared stays as it is. Secant squared turns into 1 over cosine squared. And hopefully you're starting to see now that cosine squared and cosine squared will cancel each other out, leaving you with a 1, which matches what you got right there. Now, in the spirit of showing you, there is another way to do this. I will show you the same problem a different way. Okay, same problem. All right, so cosine squared. I'm going to leave it alone. Cosine squared x plus this cosine squared x. I'm going to leave as cosine squared x. The tangent. Notice that there was an addition sign here, but it's multiplication here. So this is now times sine squared over cosine squared. Because this is multiplication, the cosines will cancel. I now have cosine squared x plus the orange sine squared x. All of this is now a Pythagorean, which is right here. Sine squared plus cosine squared equals 1. So cosine squared plus sine squared is Pythagorean, leaving us with 1, and there you go. That's two different ways to do the same problem. So, like I said, my way is not always the way to do it. You guys have traditionally in the past shown me very good ways of doing things, things I would not have thought to do. So if you come up with a different way to do it, and it is legal using identities, then you are welcome to do that. Okay, moving on. All right, so some fractions here. Not as bad as you probably think. Fractions, you should think reciprocal identities. So 1 over secant squared. This is going to be a lot like the previous problem I just did. This is cosine squared x. You get a plus 1 over cosecant squared is sine squared. I just showed you where this is Pythagorean, and therefore equals 1, and boom, that one didn't take very long. So we used reciprocal identities to get it down to here, and then it turned into Pythagorean identity, which was a 1, which equals 1, which matches what we were trying to do. Okay, again, everything you need is on this identity sheet from yesterday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 identities. And the more you understand this, the quicker and easier these will be. All right, I got 3 more. Okay, let's turn things into sines and cosines. So we're going to leave the cosine here alone. I'm going to leave that black. Cosine x. Reciprocal identity. Turn things into sines and cosines. Right here. 1 over secant. Sorry, 1 over cosecant. That will be 1 over sine. Minus secant is 1 over cosine. Okay. Now, we have at our disposal any math that we want to use. So if we distribute this, we will have cosine x over sine x minus cosine x over cosine x. So that is taking the cosine and multiplying it through to each term in the parentheses. Okay, so right here, cosine over sine. Cosine over sine is cotangent. So this turns to cotangent x. We get a subtraction. Cosine divided by cosine is 1. And if you look at what we were trying to accomplish, that matches it right there. Now, Tuesday, because I do all these lessons a day ahead. Tuesday, I had a girl in Algebra 2 ask me if I could Zoom and kind of work some problems with her. And I did. And so I offered that to you guys on Tuesday. No one took advantage of it, and that was fine, as long as you understood what was going on. But as we approach these identities, and we are verifying, and you need some help, and you want me to work it through with you, and you want to talk about it, then just text me through Remind and let me know you want to Zoom, and we can set that up. I didn't know number 8 was down here, so just kind of ignore number 8. All right, so chances are with this problem, since there's more stuff on the right-hand side, I'm going to work on the right-hand side. It tends to be the more you have, the more you can reduce and get it to equal tangent. So I'm going to choose the right-hand side of this problem. Separate into 3 fractions. Cosine x times 1 over sine x times 1 over cotangent squared x. We want things in terms of sines and cosines. So first cosine we're going to leave alone. 1 over sine we're going to leave alone. We're going to take cotangent squared. We're going to reciprocate. We're going to turn that, what we got here? All right, we're going to turn that into, oopsie, tangent squared x. That's an oops. Sorry about that. And then, just for the moment, I'm going to leave these alone. I'm going to work on this tangent squared, then we'll bring this stuff down. Tangent, I'm going to just flip this over. Tangent is sine over cosine. So this is going to be sine squared x over cosine squared x. We're going to bring these down. Times. And we'll be able to cancel. I have cosine on top and I have 2 cosines on the bottom. So what that allows me to do is get rid of one of these and all of that. And then I have a sine on the bottom and 2 sines on the top. So I can get rid of one of these and all of that. And so we are left with a sine over a cosine. Okay, well a sine over cosine is tangent. So I can say, hey, from here, this is tangent x, which matches the left-hand side. And again, if you thought of something different, you are more than welcome to do it, as long as you're using identities to solve these. Okay, these are the identities. All right, last one I'm going to do with you is number 7. Looks pretty nasty, right? And so I'm going to work on this left-hand side because there's more to do on this left-hand side than the right-hand side. What's the goal? Sines and cosines. So just take piece by piece, turn things into sines and cosines. So cotangent. That is cosine x over sine x. Don't freak out by the amount of stuff. Just take your time. Think about what they are in terms of sines and cosines. Secant. Okay, secant. Right here, secant is 1 over cosine times 1 over cosine. And so you could probably already see that cosine and cosine here are going to cancel. Okay, so just take your time, little by little. Cosecant squared. Okay, let's see. Times cosecant squared will be 1 over sine squared x. Okay, so we'll just leave it like that for now. we'll move over to the right-hand side of, well, not the right-hand side, but the rest of this. There's a subtraction sign. So that is here. All right, cotangent cubed. Okay, so that's going to come right here. Cotangent cubed is cosine cubed over sine cubed. And then the secant will be right over here. That's 1 over cosine x. Okay, so where does that leave us, right? Well, we can do some canceling. We can get rid of this cosine, this cosine. We can get rid of a cosine here and a cosine here. So that's going to be a square. So we got rid of one of these, and we got rid of one of these. Okay? So let's see what we have left. All right, so this is two parts. We got a part over here to the left and a part over here to the right. So the only thing left on top is a 1. And on the bottom, you have a sine times sine squared, which is sine cubed x. Sine to the first, sine to the second, 1 plus 2 makes sine to the third. Subtraction sign. Okay, over here, this blue fraction is completely gone. It's all gone. So what we have is the green fraction with this red exponent. So that is cosine squared x over sine cubed x. Okay, take your time, work through it. Common denominators, yay. Yay for us, right? Okay. This is going to work out really, really well. All right, so make this one fraction. So push this together, make it one fraction. 1 minus cosine squared x over sine cubed x. Okay, so one of the tricks from yesterday was Pythagorean identities have squares, pluses and minuses, and a 1. So over here, we rearranged the Pythagorean identity to give us cosine squared. We can do the same thing with this if we rearranged it for sine squared. So this top right here, this 1 minus cosine squared, turns into sine squared x over sine to the third x. And we get cancellation. You got 2 on top, 3 on bottom. So the 2 on top are completely gone, leaving you just 1 on the bottom, which really looks like this. 1 over sine x, which can be turned into, using reciprocal identity, cosecant x, which in the end is what we were trying to get. So, do you know your identities? It is really going to help. The more you know these identities, the easier these will be. Take your time, turn things into sines and cosines, use the math that you've learned for the last 10 years, common denominators, canceling, okay? Take your time. All right, so that was the last one I was going to show you. And for some reason, this printed out. So we're going to ignore that. And so here's your assignment. Again, blue packet that was given to you last Friday when we were last together. Pages 3 and 4 are 14 verifying problems. There will be no answers posted because your answer may be different from mine. And as you finish a problem, you're supposed to know that it matches one of the right or the left-hand side. So hopefully you'll know if you got it right or not. Please ask questions. If you need to Zoom because these problems are just different, let me know. I will help you, okay? Good luck. I look forward to talking with you guys. It does help my day go by a little bit faster. Have a great day, and we'll talk to you soon.